Hello friends, welcome to Expert Guidance. Today in this video we'll be covering the section Atomic Structure of Edexcel IGCSE Chemistry, and this is the topic C of your Principle of Chemistry unit. Now in this unit we'll be covering the specification 1.14 to 1.7, and in this unit we'll be looking over what exactly is atom and a molecule, what is the structure of atoms, and what are the various subatomic particles and how you write their relative masses and relative charges. Also, we'll be looking over how to define atomic number, mass number, isotopes and relative atomic mass, and we'll also be looking how do we calculate the relative atomic mass of an element from the isotopic abundance. Now this is a very important topic, so I would recommend you to watch this video till the end, as in the end I'll also give you the key terms and key glossaries which are specifically for these units. So let's begin.
What are the things that you need to cover in this chapter of atomic structure? You should know the history of atoms, like what developments were made that has given the present structure of the atom. What is the present structure of the atom? How do we do the electronic configurations, and what are ions and isotopes? Okay, so let's begin. Now, when we talk about the history of the atoms, there are 5 major scientists which names you should remember and what contribution they did in the discovery of the atom. The first one was the John Dalton, who gave the idea of atoms in the early 1800s. Then came J.J. Thomson, who discovered electrons after Dalton, and he gave the model, the Plum pudding model of the atomic structure. Then after J.J. Thomson came Rutherford. He discovered the nucleus by alpha scattering experiment, and then came the Niels Bohr, who gave the idea of electronic shells in 1940, and then finally came James Chadwick, who discovered the neutrons in 1932. So we got the first idea about the atoms in early 1800 by John Dalton, and after 1932 we came up with the final structure of the atom. So let's look at these contributions one by one. So in early 1800, there was John Dalton, and he said that everything that has mass or volume is made up of atoms, and you cannot divide atoms further. Late in 1800 came another scientist called J.J. Thomson. Now what he did was, he took a glass tube, and in this glass tube, he kept a gas at a very low pressure. The gas tube had a cathode and an anode, and it was given a very high voltage, around 150,000 volts. Now, at such a high voltage, he saw that the glass tube, it gave a green glow. And from where did the green glow came? It came from the rays that was given out of the cathode. Now, he called these rays as the cathode rays, and as they were coming towards the positive terminal, he concluded that these are the negative rays which are coming out of the gas atoms which are present in this glass tube. So he discovered that atom can further be divided, and it has a negative and the positive charged subatomic particles. On the basis of that, he gave this plum pudding model. Now, what was this plum pudding model? This plum pudding model says that atom is a sphere of the positive charge. The positive charge is equally distributed, and in this sphere of the positive charge, the electrons are embedded as raisins, and he gave the plum pudding model, and according to him, the electrons and the positive were similar, therefore atom is neutral. Now, if this model was correct, at that time, there was another scientist called Giger and Maston, which were doing the alpha scattering experiment. So what did they do was, they took a gold foil, and on those gold foil, they bombarded the alpha particles. Now, what they predicted was that if plum pudding model is correct, then majority of the alpha particle should pass undeflected from this gold foil and should hit the zinc sulfide screen. But to their surprise, what did they find was that majority of the alpha particles went off undeflected, and there was minor deflections, and at the center there was a greater deflection, and some of the alpha particles, they just bounced back by 180 degrees. Now what does this tell us? It tells us that since most of the alpha particle pass straight through, majority of the space is empty in the atom, and since there was a greater deflection at the center, there's a positive charge which is concentrated at the center of the atom. So therefore, Rutherford modified the structure of the J.J. Thomson, and he said that the positive charge which is concentrated at the center is the nucleus. So he refined the structure and he said that there's a nucleus at the center which is consisting of the positive charged elements, positive charged subatomic particles, and then the electrons are revolving around this nucleus. Then came another scientist called Niels Bohr in 1914. He gave the idea of electronic shells. Now what he observed was whenever an atom was given any energy, it was emitting this specific amount of energy. So what was happening is the electrons which were orbiting, they were taking those energies, and then when they were coming back to their ground state, they was emitting the energies. And these energies were of the specific amount. So he concluded that electrons are not just orbiting anywhere around the nucleus, they are orbiting at the specific energy levels called the electron shells. Then there was another scientist who came in 1932 called James Chadwick. What was the observation was when they were taking the mass of the neutrons and the mass of the protons, there was a mismatch. Although the atom was still neutral charge-wise, but there was different in masses. So James Chadwick discovered that there's a third subatomic particle present called the neutrons, which has no charge, but has the mass similar to that of protons, and that is present inside the nucleus along with the protons. Okay, so with all these discoveries, we came up with this structure of atom. That atom is composed of 3 subatomic particles, and this table is very, very important. You should remember each and every part of this table. You might be asked in the exam to either fill some parts of the table or maybe to make this whole table. So the atom is made up of 3 subatomic particles: electrons, protons, and neutrons. Electron has a relative charge of -1, protons have +1, neutrons have 0 charge. The relative mass of protons and neutron is 1. Electron is 2000 times less. Therefore, electrons are lighter. Proton and neutrons are found in the center, in the nucleus of the atom, and the electrons are found revolving around the nucleus in specific shells. So you can see that this is the element which has 4 electrons. So 2 are in the first shell, 2 are in the next shell, and 4 protons and 4 neutrons are in the center. This is how we make the structure of the atom. Now, how do we work out how many proton numbers, electron numbers, or neutron numbers are there in an atom? For that, we take the help of a periodic table. If you see the periodic table, in the periodic table, all the elements are there with a symbol. So this is the symbol of the element, and they'll be having one number at the top and one at the bottom. The number at the top is the mass number, which is the number of protons and neutrons. The number at the bottom is the atomic number, which is the number of protons. And since atom is neutral, so the number of protons and neutrons are the same, so the bottom number will also give you the number of electrons. So if you need to work out the electron number, you will write the bottom number if it is an atom. Remember, it has to be an atom. Then only you can say it has an equal number of electron and proton. We'll see later. There's a second category called ions, which have unequal number of electrons and protons. The proton is again the bottom number, and the neutron number is the top number. Take away the bottom number. So that is A minus Z. Okay. Next is when we have the electrons, they are filled in a specific energy shells. So the first shell can hold maximum of 2 electrons. The second shell can hold maximum of 8. Third can hold 8, and fourth can hold 18 electrons. So if we talk about sodium, whose atomic number is 11, then you will fill them as 2 in the first shell, 8 in the second shell, and 1 in the last shell. Similarly, magnesium with the atomic number of 12 means electron number is 12, will have 2 in the first shell, 8 in the second shell, and 2 in the final shell. Okay, so our electronic configuration is clear to you. Now you have in your syllabus the electronic configuration of the first 20 elements. So this is the list of the first 20 elements. So hydrogen, helium, lithium, beryllium, the atomic number is mentioned. So electronic configuration with 1 atomic number would be 1, with 2 is 2, then 3 we'll have a new shell, 2 1, 2 2, 2 3, and so on. And once all 8 electrons are filled in the second shell, with the sodium we have another shell, so with 2 8 1. So this is the electronic configuration of the first 20 elements. Now electronic configuration is very useful. Why? Because electronic configuration gives you the information whether the electrons are fully filled in a shell or not. If the electrons are not fully filled in each shell, the elements will react in order to gain full outer shell. The number of electrons in the outermost shell gives us the group number of the element. So lithium belongs to group 1, beryllium belongs to group 2. Lithium and sodium, they both have 1 electron in their outermost shell, therefore they belong to the same group. Okay, so by looking at the electronic configuration, you can get that much of information about any element. The other information you can get by looking at the electronic configuration here is that helium has the complete first outer shell, neon has complete second outer shell, and argon has complete third outer shell. These 3 elements do not have any capacity to take any other electron, therefore they are noble gases. Why? They have full outer shell, therefore they do not have to react further. On the other hand, to react, to be stable, sodium has to lose 1 electron so that it can get a full outer shell configuration. On the other hand, chlorine has to gain 1 electron in order to get full electronic configuration. So this is how we analyze the electronic configuration, and these are all the informations we can get from that. Okay, so I hope it is clear to you. Now let us move on to what are ions. Now ions are charged atoms. Charged atom means they have unequal number of protons and neutrons. And how this unequal number of protons and neutrons arise? Either by loss of electrons or gain of electron. If any atom loses an electron, it will have more protons than the electron, therefore it will get the positive charge. And if any element gains an electron, it means it will have more electrons than the protons. An atom that gains an electron will get the negative charge. Okay, now how you decide the charge? The charge depends on how many electrons are gained or lost. So if sodium has lost 1 electron, it will get a +1 charge. If magnesium loses 2 electrons, it will get +2 charge. In the similar way, if fluorine gains 1 electron, it becomes -1 charge. And if oxygen gains 2 electrons, it will become -2 charge. Okay, now let's see how the electron number changes with the ion. Now this is the sodium. You know the bottom number is the electron number. The top number, take away the bottom number, that is 12, will be the neutron number. Now sodium becomes sodium plus, means it has lost 1 electron. Now since it has lost 1 electron, the electron number will be 10, but the proton number, neutron number remains the same. Okay, so there's always a change in the electron number whenever the ion is formed. Similarly, oxygen 8 and 16, they all have 8 proton number, neutron number, and electron number. When it becomes 2-, it means it has gained 2- means gained 2 electrons. So you add 2 to their number of electrons and that becomes 10. Okay, so I hope you are now in a position to work out the proton, neutron, and electron number of an atom and an ion. Okay, so now let's take an example. Now you can see that I have made 3 tables. In one, I have put a sodium atom, and since it is an atom, it will have an equal number of electron and a proton number. I have added aluminium 3+ ions. Since it's a 3+ ions, it means it has less electrons and more protons, and oxygen 2- means it has more electron than the proton. Now you will follow the same tactic. The bottom number is the atomic number. So I've put 11, 13 and 18 in all the 3 boxes. The top number is the mass number. So 23, 27 and 16. The proton number is always the bottom number. So that is 11, 13 and 8 for all of them. And neutron number is the top number. Take away the bottom number, which is 12, 14 and 8. Now the first case is an atom, so it will have an equal number of proton and neutron. So I'll fill 11 in this column. But in the second case, the proton number and electron number will not be the same because aluminium has lost 3 electrons. So if it would have been an atom, it should have 13 electrons, but now it has lost 3 electrons. So 13 minus 3, it now has 10 electrons. In the oxygen case, it should have 8 electrons, but now it has a 2 minus charge. It means it has gained 2 extra electrons. So now it has a 10 electron. Okay, so the charge is the proton number. Take away what is the charge of the proton and the electron. So here it is an equal number, so it is 0. Here the charge is plus 3. Here the charge is minus 2. Now electronic configuration, since the electron number is 11, so 2 in the first shell, 8 in the second shell, and left over 1 in the third shell. These both have 10 electrons, so 2, 8, 2, 8, full outer shell configuration you will have for all these ions. Okay, so I hope you are able to do this, because these questions are often asked in the exam, where they give you an element and they ask you to work out the atomic number, mass number, electron number, proton number, neutron number. So make sure this table is clear to you. Okay, now next is the last concept. What are isotopes? Now if you see in this, I have made 2 tables. They both have carbon with the same bottom number but different top number. Now since the top number is different, the atomic number is the same for both of them. Electron number is the same for both of them. Proton number is the same. Now what changes is the mass number, which is 12 and 13. And since the mass number changes, the neutron number changes. This is what is the concept of isotopes. So isotopes are the members of the same elements having same atomic number but different mass number, same number of electrons and protons, but different number of neutrons. So since they have similar electronic number, they show similar chemical properties, and since they have different masses, they show different physical properties and radioactive properties. It can happen one of the isotope is stable, other is radioactive, and this is all because they have different masses. So you should know the definition of isotopes, what things are same, the similarities in the isotopes. They can ask you what are the things similar in the isotopes. So you can say atomic number is same, proton number is same, electron number is same. What is the difference in the isotope? The mass number is different, neutron number is different, physical properties are different. Why chemical properties are the same? Because the electron number is the same. And for the chemical reaction, it is the electrons that takes part. Okay, so I hope the concept of isotopes is clear to you. Now, this is all you need to do in this topic. So now here I have tabulated the important key terms of this topic. So in this topic, we have seen what an atom is. It's the smallest particle, consists of electron, proton, neutron. What is a proton? Proton is a positively charged subatomic particles with a relative charge of +1, relative mass of 1 found in the nucleus of the atom. Neutron is a neutral subatomic particle with a charge 0, mass 1, relative mass 1 found in the nucleus. Electron is negatively charged with relative charge -1, relative mass 1/3000. Remember that table, and which is found revolving around the nucleus and shells. Nucleus is the center of the atom with the positive charge, which contains neutrons and protons. Atomic number is the number of protons. Mass number is the number of protons and neutrons. Ions is a charged atom with unequal number of protons and neutrons. What are isotopes? Members of the same element with similar number of electrons and protons but different number of neutrons. Electronic configurations is arrangement of electrons in shells. Okay, so I hope all these key terms in this unit is clear to you. So now let's test yourself. So the first question is, you need to give one word of what are the positive charged subatomic particles, the negative charged subatomic particles, electrons was discovered by, neutrons was discovered by, and what was the name of the model given by J.J. Thomson. Next is, you need to answer how to work out the neutron number of any atom. What do elements in the same group have in common? Why isotopes have similar chemical properties? And you need to draw the structure of calcium atom. So you can pause the video, have a go at these questions. Okay? Right, so now let us look at the answers of them. Positively charged subatomic particles is proton, negatively charged is electron. Electrons were discovered by J.J. Thomson, neutrons were discovered by James Chadwick. The model given by J.J. Thomson is plum pudding model. How to work out the neutron number? It is a mass number, take away the atomic number. So top number minus the bottom number. What do elements in the same group have in common? They have same number of electrons in their outermost shell. So for example, sodium and potassium both belongs to group 1, have 1 electron in their outermost shell. Why isotopes have similar chemical properties? Because they have equal number of electrons, so they show similar chemical properties. Next is to draw the calcium atom. Now calcium is 40 and 20, so it means electron, proton and neutron number all is 20. Electron configuration will be 2882, so we'll draw a calcium atom. I've just drawn a tiny nucleus. You can draw a bigger nucleus showing 20 positives and 20 circles with no charge. So I've written 20p and 20n, and then you have to show 4 shells. 2 electrons in the first shell, 8 in the second, 8 in the third, and 2 in the last. Okay, so I hope this topic is clear to you. This is the majority of the things that you need to do in this topic. Now, what's the next step you need to do? The next step is check the specification. Just tick mark what are the things that you can now answer in atomic structure, and then you need to try the exam questions on this topic. Now, to do the exam questions on this topic, you can visit my website where you can get chapter-wise exam questions on this chapter. So try that and let me know how you're feeling now about this topic. So if you like this video, then do like, comment or share this video, and do not forget to click the bell icon so that you can get all the notifications of all my upcoming videos. And if there's any video that you want me to make, also leave a comment below and I'll make sure that I'll put that video up. Okay, so please do subscribe to my channel so that you can get regular updates about my next video. Okay, so I'll see you next in the next video of the mixtures. Till then, happy revising.